Our subject for today is about the friction force. The friction force simply occurs when the object is in motion, either on a rough surface or a viscous medium. Therefore, we will see a resistance to the motion, or actually the object will experience a resistance to the motion. Now, in general, the friction force is very important in our lives. For, um, for example, it allows us to walk, run, or even it's very important to the wheeled vehicles. Now, let me take the following example. For example, as you can see here, I have a block of mass M rests on a rough horizontal surface. When I mention rough horizontal surface, you have to know that we have a friction force, and this friction force should be opposite direction to the direction of the motion. Okay, now I have here a force F horizontal to the surface, and obviously the direction of the motion, if there is a motion here, it will be to the right. Now, since I have, or I'm talking about rough surface, the friction force will be opposite direction to the motion. Okay, if there is no motion, in other words, even if I have external force acting on this object and the object remains at rest, stay at rest, or still at rest, that means the friction force here is static friction force. And the static friction force equals to the summation of the external forces. Now, the second type of friction force occurs when my object is about to move. Therefore, the static friction here will be the maximum value of the static friction, which is F static maximum equals to mu s times n. As we know from before, here n is the normal force in unit of a Newton. Mu s here is the coefficient of the static friction. And you can do the following, or you can ask yourself, what is the unit of mu s? It's easy from this formula to say mu s equal static friction divided by the normal. And we know the static friction force is in Newton units and normal force is in Newton units. Therefore, mu s has no units. Okay, now what if the external forces or the forces acting on the object greater than the friction? Then my object starts moving. So if the object isn't moving, the friction force here will be kinetic friction force, which is equals to mu k times n. N, as I mentioned before, is the normal force. Mu k is the coefficient of kinetic friction. Now, pay attention to this following statement. The static friction force, always the static friction force greater than the kinetic friction force. Therefore, if we substitute mu s times n greater than mu k times n, then the normal force from the right side cancel out with the normal force from the left side. We will end up with mu s is greater than mu k. So in friction force, we have three scenarios. The first one, if the object stay at rest, so I have static friction force. If the object is about to move or trying to move, I have static the maximum value of the static friction force. And if the object is moving, that means I have kinetic friction force. And be careful, mu s or mu s is greater than mu k. So let me start with the following example. Okay, a box of mass 2 kilograms rests on a rough horizontal surface. Mu s and mu k are given. An external force of 2 I hat, which means the direction of the force is to the right, therefore the direction of the motion to the right, acts on the block and the block remains on rest. There is no motion. First, calculate the acceleration, the normal force, and the friction force. Okay, you know what? As I mentioned before, I have here block, rough surface, and acting force. Now, translate this thing into X, Y diagram showing all the forces acting on your system. This will make your stuff more easy. Okay, so normal force perpendicular, as you see here, weight, and the acting force to the right. Therefore, the direction of the motion will be to the right. Now, since we have a rough surface, there is a friction force, and up to now, I don't care about the type of the friction force. So I have friction force to the left. Okay, calculate the acceleration. From the question or from the example, the block remains at rest. That means there is no motion at all. That means, or therefore, the acceleration is equal 0. Second, the normal force. Okay, normal force here is along y-axis. All what you have to do is saying the summation of the forces along y-axis equals 0, and go to y-axis, read it. You will see N minus W equals 0. Therefore, N equals to the weight, and the weight here is 20 Newton. Number 3, find the friction force. Okay, mu s is given and mu k is given. So please pay attention to the following. Here, you cannot say the friction force, which is the static friction force, equals to mu s times n. What we have here is only the static friction force, not the maximum value. So from the previous slide, the static friction force equals only the summation of the external forces. So what I have here is only F, which is equals to 2. So the static friction force equals to 2 Newton. Another example, a box of mass 2 kilograms rests on a rough horizontal surface of mu s and mu k. Calculate the acceleration, calculate the normal force, and the friction force. Okay. Drawing the x and y axis, showing all the forces acting on the system. So we have a normal force and we have W. The acceleration here equals 0 since there is no motion. Normal force here, summation of the forces along y-axis equals 0, and we can get normal force equals to the weight, which is 20 Newton. But the friction force here is equal to the summation of the external forces. We cannot say Fs equal, or F static force equals to mu Sn. There is no motion. So we are talking about the first scenario, the static force only, not the maximum value of the static force. So since there is no external force, the F static equals to 0 Newton. Another example, a box of 2 kilograms is pulled to the right. That means the direction of the motion is to the right by a constant force on a rough horizontal surface. Rough horizontal surface tell us there is a friction force, and mu s, mu k, both of them are given. What is the minimum value of the force which is just about to move? Okay, let us take it step by step. This is my forces, my force and the object, all the way translated into x and y axis. So we have a normal force perpendicular to the surface, weight perpendicular to the surface but in downward direction, a force to the right, and the direction of the motion to the right. Since the direction of the motion to the right, the friction force will be to the left. Now, you need to determine which scenario you are talking about. So since we are saying about to move, or the object is trying to move, so we have here the maximum value of the static friction. So we have Fs or F stat max. Okay, now what is the minimum value of the force? My force here is along x-axis, and the only thing that we do care about is summation F along x-axis equals m times a. But there is no motion, there is no motion, so the acceleration equals 0. Okay, so read the whole forces along the x-axis will give you F, which is in the same direction of the motion, is going to be positive. F stat maximum will be negative because it's in the opposite direction to the motion. All of them equal 0. Now from here, the force equal F static, which is equals to mu s times n. Okay, here mu s is given, but the normal force is not given. So it's so easy to say normal force equals the weight. So all what you have to do, just substitute what you get. So here force equal F static maximum, which is mu s times n, but n equals to m times g. So now mu s is given, the mass is given, and g equals 10. So the force, or the minimum value of the force, will be 5 Newton. Okay, what if the force is not horizontal to the surface? So we will see it in this example. Due to a constant force, tension or T, acting on a cart and pulling it upward at an angle 30 above the horizontal, what is the magnitude of the force T to keep the cart moving with a constant velocity? The mass is given and the kinetic friction is given too. Okay, before going to the friction stuff, take this thing and plot your X and Y diagram showing all the forces on it will make the process more easy. Okay, as you can see, I have this T, which is unknown, but the angle is known. So what we have to do is find the x and y component of t. So we have tx and ty, where tx is t cosine theta, ty t sine theta, and the normal force, which is perpendicular to the surface upward in direction, and the weight downward. Now, since the surface is rough, so we have a friction force. That's number one. We don't care up to now. I do not care about which type of friction. So we have a friction force. Now, here, the question is saying the cart moving. That means I have kinetic friction. It's number 2. So I have friction, and the friction is kinetic friction. Number 3, the direction of the motion is to the right. Therefore, the friction force will be in the opposite direction of the motion, and it will be to the left. Okay, so I have a diagram with the whole forces. Now, what is the value of T? Let's go to the summation of Fx equals max, but the acceleration here is not given. Hold on. The question saying the motion is with constant velocity. Go back to the first or second slide. You will see if the velocity is constant, the acceleration is 0. So from constant velocity, we can say the acceleration equals 0. Okay, so let me read the whole forces along x-axis. I will find T cosine 37 minus F kinetic equal, or the kinetic friction equals to 0. Now, the kinetic friction is mu k times n, but the normal force here, be careful, you cannot say the normal force equals to the weight, same as in this example or this example. Why? Because I have y component of this force. So what we have to say, T sine theta plus normal force equals W. Therefore, the normal force equals to W minus T sine theta. Okay, now I have the normal force. Substitute the normal force here. I will find T, or I will see T cosine 37 minus mu K, all of it times W minus T sine 37 equals 0. Do your calculation, you will find T equals to mu K times W divided by cosine theta plus mu K sine theta. Everything here is given. Mu K is given, W is given because the mass is given, cosine 37 from the calculator, then you will find the amount of this force. Another example, I have a 4-kilogram box, which is M1, is connected to a bucket of mass M2 by a cord running over a very light frictionless pulley. The coefficient of kinetic friction is 0.5, and the box starts from rest. Find the acceleration and find the tension. We saw this example in the previous lecture, but the only difference from here, the only difference between this example and the previous one, there is a friction force. Okay, let us take it step by step. The first step, convert what you have here, your system, into x and y axis. So I have two masses. That means I have to have two diagrams. The first diagram will be normal force, weight, and tension to the right. Normal, there is no normal force here. Weight and tension upward. Okay, the direction of motion here, as I mentioned in the previous lecture, direction of motion here, since the weight, you can see it here, is 6 times 10, it will be 60 Newton. So the direction of the motion all the way to the right. Now the friction force will be opposite direction to the motion, and it will be to the left. Okay, now I have two systems. The first one for M2, the second one for M1. Now, to find the acceleration, I have to have two equations of motion. The first one using summation f of x equals m1a, and then I have the tension in the same direction, the friction force opposite direction, so T minus F kinetic equals m1a. But the kinetic friction here is mu k times n. The normal force here is equal W1. So I already calculated the friction force, which is 20 Newton. Now, from the second system, for M2, summation Fy equals M2A. So as you can see here, W2 in the same direction, tension opposite direction. So we can say W2 minus T equals to M2 times A. So I have formed equation number 1 and equation number 2. The tension is unknown. So adding those two equations, we will end up with the acceleration equals to W2 minus kinetic friction divided by M1 plus M2. W2's, we already have it. M1 and M2 is given. The kinetic friction force, we already calculated it and we found it to be 20 newtons. So the acceleration here is 4 meters per second square. Second part, to calculate the tension. So go back to those two equations. Acceleration is known, friction force is known. So all what you have to do is substitute the amount of your acceleration either in equation 1 or equation 2. Then the tension will be 26 Newton. Thank you so much and see you in the next lecture.